Welcome to the GCSE Statistics Higher Session 9. This session is focused on index numbers and geometric mean and consists of 4 subsections: simple index numbers, weighted index numbers, chain-based index numbers, and geometric mean. Simple index numbers. You need to be able to calculate index values from real values and vice versa. The 2 explanations here on the screen will be helpful. We're looking at the new value divided by the base year value multiplied by 100 to be able to find the index value. When working in the reverse, we're going to take our old value and multiply it by the index value. Really important point in relation to calculating percentage change is to not forget to take off the 100. When having calculated your index values, you are going to need to comment and draw conclusions related to these index values. You will be told which year to use as a base value to be able to calculate the other index values for the series of the data you have. Let's take a look at some real examples involving these calculations shown here on the screen. Example number 1. Zenith Engineering makes stainless steel. The raw materials for making stainless steel are steel, chromium, and nickel. Stainless steel is made with 74%, chromium 18%, and 8% nickel. The table shows the price in pounds per tonne for chromium and nickel in the years 2000 and 2003. Really important. Taking 2000 as the base year, calculate the index numbers for the price of chromium and nickel in 2003. So here we have our base year of 100. So to be able to find our index value for this year 2003, we take our new value. So for chromium, we have 43575. We divide it by the base year, this value here, 41,500, and times by 100. Our index value is 105. For nickel here, we take the price in 2003, the new value, 8240. We divide it by the base year value, 8,000, and we times by 100 to find the index value of 103. Weighted index numbers. If you have a product which is made of different materials, each differing proportion, like the example we just looked at, then you can calculate an accurate index number for the product based on the weightings of the materials. And we use this formula. The weighted index number is equal to the sum, that's the total, of the weighting multiplied by the index divided by the sum of the weighting. So here we have our information from the previous example that we worked out, the index values for chromium and nickel. Now, using the weightings, the percentage, for steel, we have 74%. For chromium, we have 18%. And for nickel, we have 8%. Now we're going to use this to be able to find the weighted index number. So here we are going to find the total of the weighting multiplied by the index. So let's have a look at the first one. Here we have the weighting, 74, times by the index, 102. The weighting here, as a percentage, we must divide by 100. We are then going to add the weighting for chromium, 18, divided by 100, times by 105. Add, change colour so you can see it, nickel, 8 times by 103. Adding these up to find the total, we have the weighted index number of 102.62. So this is an index number for the product based on the weightings of the materials. We're then asked to write down the percentage by which the new price of raw materials for stainless steel went up. So here we're using this, we're comparing it, the base year is always 100. So the weighted increase, you can see for all of the products here, is an increase of 2.62% increase or rise. We're now going to look at chain-based index numbers. These are index numbers calculated using the preceding year's index as the base. So this is the year before. Let's take a look here now. For an example, we have some commodity prices in the years 1994 to 1999. So first off, we're going to use 1994 as the base year. Using 1994 as the base year, we will put the index number as 100. We will then find the index number for each one of the years that follow. Now, looking here, our calculation, we are taking our value for 1995, 170 here. And we are dividing by the preceding year, 150. Taking 170 divided by the preceding year, 1994, and multiplying by 100 to give us our new index number. This here is a chain-based index number because it is based on the preceding year's value. We can see here for 1996, here, we're using 160 here, but we're using the year before to divide by 170. So we're dividing by here 170. You will see here the pattern continues with the calculations using the previous year's value. To find here are chain-based index numbers. Example number 3. The table shows how the average price of houses bought by first-time buyers changed over a period of 5 years. It also shows some of the chain-based index numbers for the average prices. The prices are given to the nearest 1,000. We're asked to calculate to the nearest whole number the chain-based index numbers for the years 2004 and 2005. Let's take a look at 2004. The price in 2004 is 121. We must divide it by the previous year. The price in the previous year in 2003, the price was 99. 121 divided by 99 times by 100 is 122. This is the chain-based index number for the year 2004. Moving on now to the year 2005, we take the price, 129, and we divide by the previous year, 1994, the value there at 121. Times in by 100 again to get our chain-based index number of 107. Again, here we can see that we're dividing by different numbers the previous year's price or value. For the years 2001 to 2005, write down the largest annual increase. The largest percentage increase, the largest annual percentage increase. Okay, we need to look at the chain-based index numbers. Here we have 125, 125, 116, 122, 107. We are looking for the largest number here. 125. This corresponds, the year 2002 here, we can see the largest annual percentage increase is not 125, but 25%. Remember, it's from 100 as the base going up to 125. Explaining why this is the largest annual percentage increase. Here our percentage is only 23, here 16, here 22, and here 7. So this is the largest annual percentage increase. The geometric mean. The geometric mean is calculated by taking the nth root of a product of n values. What does this mean? So if we have n is the number, so for example, if n equals to 4, we will have the fourth root of the product of the values multiplied 4 times, because we have 4 values. So n changes, the root changes, and the number of values we are multiplying the product will change here under the square root sign. This question is often asked when dealing with index numbers, and it will be a part of the question. When used with chain-based index numbers, you need to be aware that it will show the average annual rise. So if we take a look at the chain-based index numbers from the previous example, we had 123, 125, 116, 122, and 107. Now, finding the geometric mean of these chain-based index numbers, we are going to have to find the fifth root of all of these numbers multiplied together. So we will take the fifth root of 123 multiplied by 125, multiplied by 116, multiplied by 122, multiplied by 107. The fifth root of this is equal to 118. This is the geometric mean for these chain-based index numbers. You might be then asked what you can infer from this answer. What does this mean? Now, given that what we put up here, that when used with chain-based index numbers, they'll show the average annual rise. So here we can say that the average annual rise is equal to 18%. So the rise here is equal to 18%. You might also be asked to speak about the trend of these numbers, and you can see here that there's not really any trend. I mean, we have our numbers here are slightly higher, and there's a little bit of a dip here in the year 2003, but really there doesn't seem to be a particular pattern with these chain-based index numbers here. So it's now time for you to do some questions. You need to press pause on the video and complete the question booklet. Once you've completed as many questions as you can, come back to the video, press play, and we will go through the questions together. Question number 1. The following table shows the population of Hambleton in 1960 and in 1980. Taking 1960 as the base, work out the population of Hambleton in 1980 as an index number. So, first off, what is the population of Hambleton in 1980? 7,040. Divided by the base population, 6,400. Times by 100, index number 110. What does this mean? It means that the population has increased by 10%. We're then told that Thorpe is a town near Hambleton. The population of Thorpe decreased by 2%. Between 1970 and 1990, the 2 years here. Taking 1970 as the base, must be 100. Complete the table. Populations decreased, 98 is the new base number. Question number 2. Nikki uses old editions of her local newspaper to collect information about the average price of the houses in her area. Her results for the years 2001 to 2005 are summarised in the table. Here we have the years and here we have the prices. Nikki's using secondary data. Why? Because she's collecting the data from somewhere else, in this case, the local newspaper. We're asked here to write down one advantage and one disadvantage of using secondary data. So, an immediate advantage is that it's quick, it's easy. You do not have to do the work yourself, you're getting it from somewhere else. So it's quicker, it's easy, and in many cases, it's cheaper. You do not have to spend your time collecting the data. Getting it from a source like a newspaper does not cost very much money. Disadvantages, however, is that secondary data may be unreliable. Why? Because we do not know its origin. We do not know whether the newspaper is reporting accurate data. So it might be unreliable. It also might be out of date. So there we have the disadvantages around the reliability of the data. We're then told that Nikki calculates the chain-based index numbers for the average price of the houses for the years 2002 to 2005. Her chain-based index number for 2002 is shown here in the table, 106.7. You're asked to work out the chain-based index numbers for the next 3 years. Let's take a look at 2003. We take the price of the houses in 2003 from our table here, 137,000. We divide by the preceding year's value, in this case, 128,000. Timesing by 100 gives us our index value here of 107.03. Moving on now to the next year, 2004. Again, we take the value of the house, the average price in 2004, 145,500, and we divide by the year before, 2003. So we have divided by 100, our chain-best index number of 106.20. And then moving on to our last year here, 2005. 2005, our price, 156,500. Divide by the previous year, 145,500. Multiplied by 100, chain-based index number of 107.56. Question number 3. The table shows the price index numbers for the average monthly rental of 2-bedroom properties in Manchester between April and August. Base month, April. We can see that because it's got an index number of 100. In which month was the average monthly rental higher than it was in April? We're looking for an increase, therefore we have to have a higher number than the 100%. We can see here 110, June. 10% increase there. We're then told that the average monthly rental was £720 in April, and asked to count the average monthly rental in July. So here we're going to use our index numbers to be able to calculate real values. So we take the original amount in the base year, 720, and we multiply by our index number here, 70 divided by 100, 0.7. So we have a value of 504. Does that make sense? Have the prices gone down? Yes, base was 100, now 70. So there is a decrease. Question number 4. The table shows information about the number of registered vehicles for each of the years 2001 to 2005. We're asked to calculate the chain base index numbers for each of the years 2002 to 2005, giving our answers correct 1 decimal place. So taking our first value for 2002, we take our value in 2002. We divide by the previous year. And we times by 100. Our first value here, 102.7. Next, 2003. We take our value in 2003 and we divide by the value in the previous year. Remember, in chain-based index values, the base year floats. It changes year to year. And then for 2004, times by 100 again, we have 103.4. And then lastly, for the year 2005, exactly the same process using 2004 as the base, timesing by 100, 102.0. We're then asked to calculate the geometric mean for the 4 chain-based index numbers. We have 4 numbers, so it's going to be the 4th root. Again, using our calculator, the 4th root of our 4 chain-based index numbers multiplied together to find the product. And multiplied together, showing you're working out, is equal to 102.5. An interpretation here in this question is about the number of registered vehicles. So the number of registered vehicles has increased by 2.5% on average each year. So really important there, each year, an average rise of 2.5%. Question number 5. The table shows the monthly house price indices for 2007 to 2008. The base month is July 1983. We're asked to write down the percentage rise in house prices between July 1983, where the index number will be 100 because it's the base year, to July 2007. Looking here for July 2007, we have our value here. So how much have house prices, the index, increased from 100 to 644.3? Subtracting, we get 544.3. We're then asked to describe what happened to house prices between July 2007 and July 2008. So looking here, we can see increase, 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 decrease, 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 decrease. So with increases until October, there's a further increase there until October 2007, then decreases. So it's really important there that you identify that there's an increase followed by a decrease. In March 2007, the value of a house, that's the real price, was $191,500. So this is in March 2008. So we're looking here at this index value. We're asked to work out the value of this house in April 2008 based on the indices in the table. So we take the value in April here, which is the index value, and we divide by the March value, 620.1. Then we multiply by the real price here in March, 191,500. This then gives us the value for the house of the price of the house in April 2008, 188,597. So here to recap, just label this up. This is the price in April. Here is the price in March, the index, I shouldn't say price, index in April and index in March, multiplied by the price in March. And that's going to give us the real price in April. We're then asked to work out the percentage change in prices between July 2007 and July 2008. So the two values we're looking at here now in the table are July 2007, the original here, and July 2008. So that's for this part here, D. So we're going to find the difference between them. So we're taking the difference here, 574 minus 6 or 4.3. And we're dividing by the original, which we know is 644.3. Taking that and multiplying by 100, I should pop that in there, will give us the percentage change. So make sure adding in the multiply by 100 gives us negative 10.9%. So we can see here that we have a decrease, a percentage decrease. We're told that the indices in the table are given monthly. Write down a reason why it might be better to give quarterly or annual price indices if you are interested in long-term changes. So by increasing the time over which you are recording the prices, either quarterly every 3 months or annually every 12 months, this will mean that you even out small changes. We can see here that month by month we are seeing fluctuations. So by increasing the time period, we will minimize these fluctuations. We will even out the small changes. And also we will decrease the amount of data to be analysed if we are only collecting it 4 times a year or indeed annually once a year. Question number 6. The population density, which is the population divided by the area in hectares, for each of 3 towns in Devon is given in the table below. We're asked to calculate the geometric mean for the population densities of Exeter, Plymouth and Brixham. So we have 3 values. We're going to find the third root of our values here multiplied together. Again, using our calculator, we have a geometric mean of 21.69. We're asked, why should a geometric mean be used for this data? Now, the geometric mean in this example is used because comparing proportions is more representative instead of comparing numbers. So here, the geometric mean is useful for comparing proportions is more representative. Question number 7. Part of the wage bills of a factory in thousands of pounds for the years 1999 to 2003 are shown in the table below. Some index numbers are shown, base year 1999. See here, 100, 1999. We're asked to work out the index number for 2003. What's the wages in 2003? 320, divided by the wages in the base year, 200, times by 100. So our index number here is 160. We're then asked to work out the wage bill of the factory in 2001. This is working backwards now using the index number here, 1.25, multiplied by the wages, the real value in the base year, 200, which gives us 250. In the table here we write 250, but when we're actually working out the wage bill, remember this is in thousands, so it's 250,000 pounds. We're then told that the base year is changed to 2000, and then asked to work out the new index number for 2002. So we take the value in 2002, 300, here in the table. So the value here in 2002, and we divide by the value in the new base year 2000. So we're dividing by 240, we're timesing by 100, which gives us the new index number for 2002 as 125. We've now come to the end of session 9. Please review the list of topics shown here on the screen and replay the video for any section that you would like to study again.